Saxon's Trig, Lesson 14, Section C, page 110, begins our discussion about rectangular and polar coordinates. Now, we know that if we have a coordinate point, that we're going to have it as an x first, then a y, and we're going to see it in a parenthesis. And this, as I just said, can be a coordinate point or what they have termed in this lesson a rectangular coordinate. And then they introduce us to something new, which is it means the same thing to write. So if I give an example here of 3, -4, it is the same thing to say a rectangular coordinate as 3i, and then I'll explain that little symbol in a second, minus 4j, and again, I know that's written weirdly. This is the same format as this rectangular coordinate. I can write them this way. This is the standard way you will see something that can be converted over to polar coordinates. So when we want to graph a dot, we tend to see it in this way. When we're dealing with vectors and other things, we tend to see it in this format. Okay, so why did I write this I and this J in this funny way with this little extra piece on the top, not just a dot? Because when I do a regular I, that means imaginary numbers, which came from the square root of -1. This is a carat. I sometimes call it caret. I don't know why. And so if I ever slip, you'll know that I actually mean a carat. And the book says that some students call it a hat because it kind of looks that way. But this is the standard format with that extra little, well, technically they have the dot and the symbol. I get to shortcut and I just leave the dot off. But you get the idea here. So we have an ordered pair. We're going to write it in this format. Now, when I convert from this format to another format, the polar format, what I want to convert it to has a hypotenuse and an upside down division box that I'm then putting the degree inside of. So eventually there is a chart, and I'll get to the lower level of that chart later, but this is the rectangular side, and this is what we call the polar side. And typically the rectangular coordinate point is listed with the I and the J. The polar format is in this one. And then to add confusion, this works for regulars. The other half of the chart is actually the irregular numbers where we end up with the actual I being here. And that's why they want to make sure you know what you're doing up here before we throw in the imaginary numbers. So if I were trying to convert, I'd need a 4-quadrant grid, Cartesian plane, however you want to call it. And this is telling me, just like this is, that I'm going 3 sections to the right and negative, meaning down, 4 sections. And this is where that dot is. I then need to create a triangle in order to convert it over to having a hypotenuse, because I can't have a hypotenuse unless I have a triangle, and finding a degree. You always, 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 always connect from this dot to the center here for the degree piece and straight up to the x-axis. You never connect it sideways to the y-axis. And the biggest mistakes I see in why students can't handle these problems is because they've connected the wrong way and they get lost. So I know that this side can be labeled a 3, this side can be labeled a 4. It's technically -4, but since I know I don't need the signs for this part, I'm not going to bother to write it. The first thing I need to solve then is for the hypotenuse. So I want to find it. I can Pythagorean theorem, because this is always, because it connects straight up to the x-axis, and 90 degrees. So we can do 9 plus 16 is 25. And that means it's what number squared is 25. So the hypotenuse is 5. And it would be outside of my upside down division box. And then inside, I would need to find the degree. So rather than, now this one works nicely because this was a 5, that I can fill in here. However, a lot of times you'll get a decimal for one of the other things that you're solving for. You want to avoid using the decimals if you can. So rather than using the answer that I just found, I tend to use the originals that I'm given unless they're in decimal, and then you can just use whatever. So now I need to find the degree inside here. So what will help me if I use the 4 and the 3? 4 is opposite the x, 3 is adjacent to the x. Which word uses opposite and adjacent? Tangent of the x equals opposite 4 over adjacent 3. On my calculator, 4 divided by 3. I want a degree, and when I need the degree, I use the inverse, shift, or second, however you do it. So the inverse tangent of 4/3 will give me the answer for what x is, and then I can fill that in for the degree. Let's say for practical purposes at the moment that this came out 50 degrees. I can, in here, not really write 50 degrees because 50 degrees should fall in quadrant 1 and I'm in quadrant 4. So I can say negative 50 degrees because that's working backwards, or I can say from the 0 all the way around to this line is worth how many degrees? Well, I'm just shy of a full circle of 360 by 50 degrees. So I can say for a positive degree, 310 degrees. So negatives are going to go from the 0 backwards. Positives are going to go counterclockwise. No, clockwise. Nope. I said it right the first time. Counterclockwise, clockwise is rolling this way. So if I'm going clockwise, that's providing me with the negative, and that can be confusing, I know. Okay, so since I've covered the basics, in section D, they actually want you to do these conversions. So in example 5, they give us negative 3i plus 2j, and they say convert it to polar form. Write 4 forms of the answer. So we're going to begin with graphing. Negative 3, positive 2 gives me the dot. Always connect to the center coordinate point 0, 0 and straight down to the x-axis. We do not know our degree. We know that this is 2. We know that this is 3. Since we're converting, I'm heading to finding the hypotenuse. So let's square 3 squared to 9, 2 squares to 4. That's 13. So my hypotenuse will be square root of 13. So for my for all 4 of my answers, I will have square root of 13. 2 of them will be negative because it said 4 forms. So this happens every time. I have a positive set of 2 and a negative set of 2 for the hypotenuse. And when I get to finding the degrees, this is what's happening. Once I fill in the degrees for the positive, I flip it to its opposite corner, and when I do that, it negates the hypotenuse. And so when it flips here, that's when it turns into the negative hypotenuse. Can you really have negative length of lines? No. So these aren't really there, but they are the other form, and it said I had to write all 4 forms. Okay, back here to find the original degree. We need, again, I'm going to avoid this one because it's a decimal. So tangent is going to be the opposite and adjacent. Tangent of the unknown is 2 over 3. 2 divided by 3, inverse second tangent, however you want to do it. Oh, x equals, and that first one should spit out 33.69 degrees. So for this first answer in my list, I know that I'm always starting from 0, 0, and I'm going around till I hit this line. So how many degrees is this? If this line, oh, we didn't stop and talk about this. This is 0 degrees. This is 90 degrees. This is 270. Oh, fiddle, 180 degrees, I knew better than that. Straight line's worth 180 degrees, 270 degrees, and then all the way back around, this forms 360. So I'm just shy of 180 degrees here for this line by 33.69 degrees. So 180 minus that fills in at 146.31 degrees. Okay. And that's the positive direction. Before I flip it, I also get its negative direction. So I know this will be a negative degree. 180, because I'm working backwards. So backwards, this is, I guess I should write it out. When you go backwards, this is 0, this is negative 90, negative 180, negative 270, negative 360. So I'm coming from 0 backwards past the 180 by the extra 33.69. So we're going to add that together and get negative 213.69 degrees. Okay, now we flip the quadrant down to here. So the first one is easy if I go ahead and do the negative one, I'll write it down here. So that's straight up negative 33.69 degrees. And the positive one goes from here all the way over to here. So I want to be shy of finishing 360 by 33.69. So 360 minus that gives us 326.31 degrees. And these are the 4 answers that I need to box. And I realize that was fairly long, but they do one more example. So example 6 says, now let's do the opposite. Let's convert negative 13 as the hypotenuse, and they're giving me negative 253 degrees. We're going to graph negative 253. Negative tells me I'm moving this way. Negative 90, negative 180, negative 270. Ooh, I'm somewhere between negative 80 and negative 180 and 270. I always come from the center to wherever that dot may be, and I form my triangle coming straight down, always connecting to the x-axis. So to fill in my degree, since I went this way and that used 253, how much is inside my triangle? This was 180. Subtract that off. So 73 should be filling into my triangle. And my hypotenuse was negative 13. Ooh, I have a slight problem there because this is in negative form. So I'm going to have to flip it to its opposite corner. Now, so my hypotenuse can be 13, and this is still 73 degrees. And it wants me to convert it to rectangular form. So I need to know my x value and my y value so that I can write my answers with the I and j. So since I want to find the adjacent and I know the hypotenuse, that's so. Sine of 73, no, not sine, cosine, oh my goodness, adjacent, adjacent over hypotenuse of 13. To solve for the y, sine is opposite, which is the y over the hypotenuse of 13. So this is the easy one to do on the calculator. Cosine of 73 turns into a decimal times 13 and gives you the x answer, 3.8. And sine of 73 times 13 gives you the y answer at 12.43. So I'm moving over and down to get to this coordinate point. So if I were writing it in a coordinate point, I would be saying 3.8 and negative 12.43 because it went down, and that's the coordinate point. But since I started in polar format, I know that I don't want it in a coordinate point format. I want it the same thing with the I and the J as the correct format for that answer.